Good afternoon, everyone. Let us start. We have been conducting geography practicals, and today we shall learn a new chapter, that is chapter 2, data processing. So let me present my screen. So this is the new chapter, data processing, chapter 2, and today's date 29/10/2020. So after this class, you may write down these activities and notes on your practical notebook. So let us start with the measures of central tendency. Okay, its concepts. So let us read together. The statistical measure techniques used to find out the center of distributions are referred as measures of central tendency. Okay. The statistical techniques used to find out the center of distributions are referred to as measures of central tendency. Actually, when we have a series of data, okay, like this, for example, this is a series of data. Uh, okay, say for example, and C. And when we have a series of data like this, their representative value is always tend to concentrate in the middle of the series, okay, in the center of the series or in the middle of the series. This is what I call measures of central tendency. And the number, okay, the number denoting the central tendency is a representative figure for the entire data set, because it is the point about which the items have a tendency to cluster. The number denoting the central tendency is the representative figure, okay, for the entire data set. For example, in this case, for the entire data set, let us say the representative figure is 5, and so this 5 is the representative figure for the entire data set, and this figure is always to have a tendency to cluster, to locate in the middle of the series. Okay. So the measures of central tendency are also known as statistical averages. Measures of central tendency are also known as statistical averages. And measures of central tendency or averages are usually of the following types. So we have two important types. Okay, the first one, it can be categorized. Okay, it can be the measures of central tendency can be categorized into two. The first one is the mathematical averages. The second one is the average of position. And we have three important mathematical averages, that is arithmetic average or mean, number two geometric mean, and the third one is the harmonic mean. And about the averages of position, we have this median, okay, and we mode. So these are two important averages of position. So any question from your side regarding measures of central tendency? So measures of central tendency uh, is the statistical technique used to find out the center of distributions of a data set. Okay, and here, So let us learn the meaning or the concepts of those statistical averages. The first one is mean. I think you are very much familiar with mean. Mean of a series is the figure obtained by dividing the total values of the various items by their number. So mean is the value obtained by dividing the total values of the various items by their number. That means we have to add all the values together and to be divided by the number of items. And that is what we call mean. And next we have this geometric mean. So geometric mean, GM is the n root of the product of n items of a series. Thus, geometric mean of 8, 9, 12, and 16 would be the fourth root of the product of these four figures. That means geometric mean of this 8, then 9, then 12, and 16 will be the fourth root, okay, of the product of these figures. And if the number of these items are 5, for example, it must be 5. Okay, so in the other case, if the number of items, say for example 2, then 3, 4, 5, and then 6, so it must be 5. Okay, 1, 2, 3, 4, 5. So the fifth root of the product in this case. So symbolically, this geometric mean is equal to, okay, this n square root of this x1, then x2, x3 up to the this xn. Okay, and x refers to the values of the variable. And if the number of items is large, okay, if the number of items is more than 30 or 50 or 100, and the size of the values is very big, if the figures are very big, calculation have to be done with the help of logs. In other words, okay, geometric mean is the anti-log of the arithmetic average of logs of the values of a variable in terms of logs. Okay, it can be expressed in this way. A log geometric mean is equal to log x1 plus log x2 plus log x3 plus up to log xn, up to the n of the this series divided by n. N is the number of these items. Or geometric mean is the anti-log, okay, of this log x1 plus log x2, then up to the this xn, log xn divided by n. Actually, we should not calculate, we should not conduct any activity about geometric mean, but you must know that geometric mean is used to find out the human development index. Okay, geometric mean is used to find out the HDI, human development index. And I also have conducted one class about the calculation of HDI earlier. And next we have this harmonic mean. Okay, this is another type of this central tendency. So harmonic mean of a series is the reciprocal of the arithmetic average of the reciprocals of the values of its various items. Harmonic mean of a series is the reciprocal of the arithmetic average of the reciprocals of the values of its various items. Thus, the harmonic mean of 2, 4, and 8 would be reciprocal of this 1 by 2 plus 1 by 4 plus 1 by 8 divided by 3, or this 7 by 8 by 3. So it will be like this. See, then 8. Okay, how I think you may be doing how it is calculated. So let us find out the LCM. Okay, this 2, then 4, then 8. So 2, this 1. Okay, then 2 to 4, then again 2 4 8, and again 2. This is 1, then 1, then 2. That is LCM is equal to 2 into 2 into 2. That is 2 to 4. 4 into 2 is 8. Okay, so in this way we have got this 8. Then about 7, see 8 is there. Then if you divide 8, if you divide, yes, 8 by 2, then what do you get? 2 4 8. Okay, so let me write 4 here. Then about this 4, this 4 to 8, then plus 2. And then what about the last one? Then 8 by 8 is 1. Okay, that means plus 1. So 4 plus 2 plus 1 is equal to 7. So in this way is 7 by 8. Okay, then by 3. And if you multiply this I3, so I3s are 24 here. 7 by 24 or 24 by 7 is equal to 3.43. So in this way harmonic mean is obtained. And this one also will not be discussed in detail, simply I'm introducing. Okay, and next we have another one, that is median. Okay, median, we shall calculate median. Median of a series is the value of the item, actual or estimated, when a series is arranged in order of magnitude, which divide the distribution into two parts. That means median is the value of the series, okay, which is merely located in the middle of the series when the data is arranged in the ascending or descending order. Okay, median of a series is the value of the item, actual or estimated, when a series means a series of data is arranged in order of magnitude. That means either in ascending or descending order, and this median value will divide the series of data into two parts. That means median is located in the middle of the series, okay, of the data set. And next we have this mode. So mode is the most common item of a series, and generally it is the value which occurs the largest number of times in a series, the value having the maximum frequency, in short. Okay, mode is the most common item of a series. Of course we are going to compute mode also, and a mode is generally the value which occurs the largest number of times in a data set, in a series. Okay, up to here, any question? Boys and girls? And next, let us see the empirical relationship between mean, median, and mode. Let us read. Let us read about the relationship between mean, median, and mode. In a symmetrical distribution, mean, median, and mode are identical and have the same value. So as a symmetrical distribution, if we represent graphically, okay, so this is the case of this symmetry. Okay, see here, this is the case of symmetry. In a symmetrical distribution, mean, median, mode are identical, are the same, and have the same value. However, in the actual life, most of distributions are not symmetrical. They are skewed. Not symmetrical means, say, sometimes it may be like this, or sometimes it may be like this. This is what I call this asymmetry or skew, and this is what I call symmetry. Okay. In cases of moderately skew or moderately symmetrical distributions, the value of the mean, median, and the mode have the following empirical relationship. Okay, mathematical relationship, which is given by Carl Pearson. So here, this shows the relation. This tells the relationship among the mean, median, and the mode. So let us see. It is given by Carl Pearson, a famous statistician. So here, mode is equal to mean minus 3 mean minus median. Okay, thrice mean minus median, or mean is minus or mod is equal to mean minus 3 mean plus 3 median, or mod is equal to 3 median minus 2 mean. So this is the ultimate result. Okay, mod is equal to, here mod is equal to what? 3 median minus 2 mean. Okay, mod is equal to 3 median minus 2 mean. So this is the relationship, and from this relationship, okay, from this relationship, that is mod is equal to mean minus 3 mean minus median, we can derive these two equations. Mean minus mod is equal to thrice mean minus median, or mean minus median is equal to 1/3 of mean minus mod. That means we can see that the difference between the mean and the mod is 3 times the difference between mean and median. Okay, the difference between mean and the mod, see here, the difference between the mean and the mod is 3 times the difference between the mean and median. Okay, in other words, median is closer to the mean than mod. So this is about the relationship between mean, median, and the mod. In your textbook, you may find it graphically. Okay, but here we are expressing in terms of equation. If you read your practical textbook, you will find graphs about the skewness, okay, about the symmetry, asymmetry, okay, positive skewed, negative skewed. You will find those diagrams, but here we are expressing in forms of equation. So these are the important concepts or the theoretical aspects related with the measures of central tendency. So before we start some important activities, or do you have any question? Okay, let us continue. So now let us start activities. Here today we shall conduct only this calculation of mean, okay, computation of mean from raw data. Here we have activity 1. Here is the question. Calculate the simple arithmetic average of the following items. So these are the series of data, okay, 20, 50, 72, 28, so on. And here we are using this direct method. Okay, so let us read the formula first. Suppose the values of a variable are respectively these x1, x2, x3, xn. So these are the x's. Okay, x1, and then x2, then x3, so on. Okay, x4 up to this xn. The arithmetic average is represented by this x bar. Then mean is equal to in this way. Okay, 1 by n x1 plus x2 plus x3 up to xn. That means mean is equal to x1 plus x2 plus x3 up to xn divided by n. So n is the number of items, or it can be expressed in this way also. Okay, so mean is equal to summation x by n. X means values of the variable, and sigma, okay, it refers to the summation or total. Then n refers to the number of items. So summation x means total okay, values, the total values. So here is the calculation. You may present it in the form of table also. Okay, so to conserve the space, I am doing like this. So mean is equal to you have to add all the values. Okay, see, for example, 20 is here, 20, then we have 50. So in this way, just we have to add all these value up to this 79, and to be divided by the number item, that is 15. Okay, the number item here is 15. You may count it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So to be divided by 15. So if you add all this value, we have got 121 divided by number item 15. So we have got 54.73. So this is the arithmetic average of the series. And next we have this shortcut method. Okay, the first one is the direct method, and we have the shortcut method. Actually, when the data, okay, size of the data is big, and if the series, okay, if the number of items are many, then it will be very difficult. The direct method will be very difficult. So we have to use this shortcut method. In that case, it is also given here. The above method of the calculation of arithmetic average can be used only when the items are few. Okay, the number of items are few and the size of the figures is small. When the values are small, it is okay. If the values are very big, it will be very difficult. So to remove this difficulty, shortcut method is used. So we can assume only any arbitrary mean. Okay, we can assume any arbitrary mean to find out the deviations of items from this assumed mean. If this total is divided by number of items and add that to the to the assumed mean average, we shall get the actual arithmetic average. And symbolically, it is expressed in this way. Okay, x bar, that is mean, is equal to a plus summation dx by n, where x bar is the actual arithmetic average, a is the assumed arithmetic average, summation dx. So this is the sum of the deviations from the assumed mean, and n is the number of items. So this is a formula, okay, for the calculation of arithmetic average. Shortcut method from individual series. So here is the calculation table. Okay, calculation table. So we are producing in this way, and here size of items we express, we denoted it as x. Okay, so these are the x's, and here we are assuming this 50. Okay, this is the assumed mean. Okay, we tag 50 as the assumed mean, and deviation is obtained, okay, from here. See here, deviation from an assumed mean 50 is taken, and so 20 minus 50, okay, So 20 minus 50 is equal to minus 30 in this way. Then 28 minus 50, so on. Okay, 28 minus 50 is equal to minus 22. In this way, deviation is obtained. Okay, and next we have 53 minus 50 is equal to 3. This is plus 3. Okay, so in this way we get the deviations. After that, we are adding all the values. Okay, that is summation dx, and here this is the summation dx, and this is the total number of items. You may count it. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So the number of items are 15. Then so here mean is equal to 50. 50 is what? Assume mean. Okay, assume mean. Then after that, here we have a summation dx. I think you may be remembering the formula. So x bar is equal to a plus that is summation dx by n. So this is the formula. Just compile okay, all this number here, 71, then 15 is here. Just divide 71. Okay, just divide 71 by 15. So we have got 4.73. Then 50 plus 4.73 is equal to 54.73. So this is the arithmetic average. So in this way, mean is calculated. Okay, from the individual series using shortcut method. Okay. Any question from your side?
No, sir.
Okay, then up to here for today. And after this, I will send these plans, okay, this activity uh, through the WhatsApp group. So you have take it down on your practical notebook. So thank you very much for joining my class.